In this video, we're going to learn how to make calculations using the right number of significant figures. So we're going to start with addition and subtraction, and if we're adding the lengths of these two lines, we need valid measurements of the lengths of each line individually. So the first thing we'll do is estimate the red line. I see that it's between 70 and 80 centimeters, so I know the 7. I'm not sure about the next digit. I'm going to estimate that it's 3. So we'll say 73 centimeters. Now with the green line, this is measured with a more precise ruler, and it looks like it's 51 for sure, and I'm going to estimate that it's 51.4 centimeters. So that 0.4 is my estimate. And when I add them together, mathematically, I get 124.4 centimeters. And mathematically, that is my answer, but scientifically, that cannot be the answer that I report. You will see that there are 4 significant figures in the answer, and there are 3 in one measurement and 2 in another. That actually is not important here, the number of sig figs overall. What is important is, what is my least precise measurement? So, of course, the least precise measurement is the measurement of the red line, and so it's only precise to the ones digit, and that is our limiting factor. So what we have to do is we have to cut off the 0.4 and make it 124 centimeters. That is the length, or the sum of the lengths of these two lines, because our ones digit is that's as precise as we'll go in our answer, because our least precise measurement is only precise to the ones digit. And that works with both addition and subtraction. Now, when we get to multiplication and division, we have to do things a little bit differently. So here we're going to be measuring the density, or calculating the density of a piece of steel. And volume by displacement, we have 22.4 minus 13.5 is going to be 8.9 milliliters is the volume of the piece of steel. I know this because I had 13.5 milliliters of water. When I added the steel, it went up to 22.4 milliliters. And that difference is the volume of the steel. It is 8.9 milliliters. I also know that the mass of the bar is 69.658 grams. So if I'm calculating the density, I know that density is equal to mass over volume, and that is equal to 69.658 grams. And I'm dividing it by 8.9 milliliters. And you can tell already that the 69.658 grams, that mass measurement is very, very precise, but the volume is not. What I actually find is that our density is equal to 7.8267, and it keeps going from there. Grams per milliliter, but really I cannot report all that precision. With multiplication and division, we have to look at our least precise measurement again, and our least precise measurement is going to be determined in terms of the significant figures. So in the first measurement, the mass, that is precise with 5 significant figures. 1, 2, 3, 4, 5. Our 8.9 milliliters, that is precise to 2 significant figures. And so what I need to do is report my final answer as having 2 sig figs. Therefore, we have 7.8 grams per milliliter. And that's my final answer, precise to 2 significant figures. Hope this video has been helpful.